Hello everyone, this is Amika Mahajan. Welcome to my channel. This video is focused on electric field in vector notation. That means vector form of electric field. Basically, we know that electric field is a vector quantity because force is a vector quantity and electric field is given by force per unit test charge placed at that point where we want to find the field, and that test charge is vanishingly small. Because electric field is a vector, it is better to write in vector form. Now, how can we write? If I want to find electric field at point where charge Q node is present, actually it is the point P. We want to find field due to charge Q at point P, then I will place vanishingly small test charge Q node at point P. Then force between Q and Q node is given by 1 by 4 pi epsilon naught Q1 Q2 magnitude upon R square. Now, if I have to convert it in vector form, what I have to do? I have to multiply this magnitude by a unit vector. So F vector will be magnitude of F multiplied by unit vector. Which unit vector? It is unit vector along the line joining Q and Q naught. That means R cap. So I multiply this magnitude with R cap. So what I get? Force in vector form, and we know that R cap is R vector upon magnitude of R. So when I replace this R cap by this term, then what I get? 1 by 4 pi epsilon naught Q1 Q2 magnitude R vector upon R cube. If I write R cap in numerator, then R square will be in denominator. If I write R vector in numerator, then R cube will be in denominator. So this is the force in vector form. Now, what we have to do? We have to write electric field vector in vector form. So this electric field is F by Q naught. This is the magnitude of electric field. When I divide force by Q naught, this test charge will cancel. Now, this will be the expression for electric field. Again, if I have to write in vector form, I have to multiply with some unit vector. So E will be multiplied by unit vector R cap to get electric field in vector form. So this is the formula in which electric field in vector form is 1 by 4 pi epsilon naught Q magnitude R cap upon R square. But already I have told R cap is R vector upon R magnitude. So if I replace this R cap by R vector by R magnitude, then I get E vector 1 by 4 pi epsilon naught Q magnitude R vector upon R cube. Now, if this charge Q naught is present in space, it is present at point P whose vector distance from Q is R. Then to find electric field of Q at point P, this Q naught test charge is placed here. So what will be the electric field? Force per unit test charge. So when I divide by test charge, then Q naught will not be there in electric field term. So in vector form, I have to multiply this magnitude 1 by 4 pi epsilon naught Q magnitude upon R square by R cap. And this R cap can be written as R vector upon R. So I get E vector is 1 by 4 pi epsilon naught Q magnitude R vector upon R cube. So this is electric field in vector form. Now we should keep in mind that for a positive source charge, the electric field will be directed radially outwards from the charge. This is the charge. So electric fields are radially outward. But if we have a negative charge, if negative source charge is there, already we have told that what is source charge and test charge. Source charge is that whose field to be determined at some point. And test charge is placed at that point where we want to find field due to source charge. And this test charge is vanishingly small. So for a negative source charge, electric field lines will be directed radially inwards towards the charge. So this is how electric field lines act. Now, very important point, that point charge has a spherical symmetry. What is the meaning of this? If I have a charge plus Q here, then if I take same distance away from the point charge plus Q, because it is positive charge, so electric field lines are radially outwards. I mark point at each line at equal distance from plus Q. So what we find that electric field due to a point charge is same on this sphere where charge is present at its center. So at equal distances from the charge Q, the magnitude of its electric field is same. This is known as spherical symmetric charge. So point charge is spherical symmetric charge. If we want to express electric field in terms of position vectors R1 and R2, now what happens? Suppose this is the point A at a distance R1. This is the point B at distance R2. One charge is present at point A. We want to find electric field due to this charge at point B. Then how can you express in position vectors form? For that, we should keep in mind that if I want to find field at point B, then R2 is the final position, R1 is the initial position. So it will be final minus initial. This will be R21 vector, displacement vector between A and B points. Now, if I have to write electric field due to this source charge at point B, what I do, I place vanishingly small test charge Q naught at B. Here Q is the source charge. So if I want to find electric field, then what will be the force acting on Q naught? 1 by 4 pi epsilon naught Q naught upon, now it is from A point to B point. So final point is B, whose position vector is R naught and position vector of A is R. So here it will be R naught minus R cube, and in numerator it will be R naught minus R vector. But because I have to write electric field, it will be force per unit test charge. Test charge should be vanishingly small. Then what happens? This Q naught will cancel with this Q naught, and electric field in position vector form will be 1 by 4 pi epsilon naught Q upon R naught minus R bar cube, R naught minus R vector. So in this way, we can express electric field in vector form. Thanks for watching this video. Like, share, subscribe my channel.